So I discovered that the sum of n terms of an arithmetic progression is given by q times n squared plus p times n, where p and q are constants. So we need to obtain the common difference. So let's begin. So here we will consider the first term be denoted by the letter a in lowercase. Now, and let's call the common difference as d. Now we know that the nth term is given by an equals to first term plus n minus 1 times the common difference. And here the sum up to n number of terms, so this is given as qn squared plus pn. So if we replace n with n minus 1, then we are going to obtain the sum up to the previous term corresponding to nth term. So s of n minus 1 will be equals to q times n minus 1 whole squared plus p times n minus 1. So what we are doing here is we are substituting the value of n with n minus 1. So we have q multiplied to n squared minus 2n plus 1 plus pn minus p, which will be equals to qn squared minus 2nq plus q plus pn minus p. The reason we try to find out the n minus 1, the sum up to the n minus 1 terms, because if we subtract the sum of the n minus 1 terms from Sn, then this is going to give us the nth term. The logic is like this. So let's think that we have let's say we have 4 terms. So let's consider this is S4, and if we have S3, so S3 will be A1 plus A2 plus A3. So that means S4 can be actually represented as A1 plus A2 plus A3. So the first 3 terms, that's actually the sum of the first 3 terms plus A4. So if we subtract S4 minus S3, and this is going to give us the fourth term, which is A4. So that's what we have done here. So we consider the nth sum up to the nth terms, and from it we are subtracting the sum up to the n minus 1 terms, and on doing that we obtain the nth term. Fine. So we know that we are already provided with the value of Sn. So Sn is given as qn squared plus p times n. So from it we are going to subtract the sum up to the n minus 1 terms, which is this particular expression. So we have negative qn squared plus 2nq minus q minus pn plus p. So here we can cancel out positive qn squared and negative qn squared, positive pn and negative pn. So this is going to give us the value 2nq plus p minus q. So this is our nth term. Now that we have our nth term, we can obtain the previous term to an, which is a will be an minus 1. Now all we have to do is replace the value of n with n minus 1. So we are going to get 2 times n minus 1 times q plus p minus q. So let's further simplify this. We're going to get 2nq minus 2q plus p minus q. Now our goal is to obtain the common difference. So to find out the common difference, all we have to do is we consider the nth term, and from it we are going to subtract the previous term, which is an minus 1. So our nth term is 2nq plus p minus q, and from it we are going to subtract the n minus 1 term. So this will be negative 2nq plus 2q minus p plus q. So here negative q and positive q goes away, positive p and negative p goes away, positive 2nq and negative 2nq goes away. So we are only left with 2q. So that means the common difference is going to be equals to 2q.